raise your hand if you got experience with Flutter. All right, so there's a few people in the room. All right, cool. This is a pretty introductory level talk, so we'll go over Flutter and what it is for everybody who doesn't have any experience. So I'm Ryan Edge, and today we're talking about building applications full stack with Dart and Flutter. Just to give you a little bit of my own personal journey with Flutter, I've been working with Flutter since about 2018. Prior to that, I was mostly a full stack developer using everything from Java to .NET, React, Angular, front ends, all of that. Discovered Dart in, I want to say 2014. Thought it was really cool, but it would probably be too hard to convince my team to learn another language when they were already struggling with JavaScript. So thought it was cool, found out about Flutter back when it was Sky, kind of paid attention to the community, and then once Google I/O would announce Flutter, that was when I used it as an indicator to start ramping up on the technology. All right, so again, my name is Ryan Edge. You can find out everything about me, my socials, contact information on ryanedge.page. I like to call myself a full stack developer with a front end lean. So if you've ever done full stack before, you know that you're really not a master of everything. You're normally really good at one thing, and you're dangerous in everything else. So I tend to specialize in front end. You probably don't want me architecting the database by myself. I build applications for web, desktop, and mobile. I have a special affinity for Flutter and React. Outside of work, I love anime, I love movies. I went to my first movie festival this year, Overlook Film Festival in New Orleans. It's a horror film festival, it's a lot of fun. And then also, I played sports all the way up until college, so I ran track, played basketball, all that jazz. All right, so what's today's agenda? We're gonna start out by talking about cognitive load, what it is and why it's important for software developers. Then we're going to talk about the two different ways that developers normally work, which is developing horizontally versus developing vertically. And then sort of tacking on to developing vertically, we'll talk about developing products using a single language stack. And then finally, we'll talk about some options for the backend when you're building Flutter applications. All right, so this week, I discovered that a large majority of developers are unhappy. So according to Stack Overflow's survey, only 20 developers, or 20% of developers are happy. I'm sure all these people in this room are happy, so it's none of y'all. But for the other 80%, some of the common frustrations are they kind of feel like they're drowning in technical debt. And then also the complexity of their tech stack, specifically around building applications and then shipping them. So that kind of brings me to cognitive load. What is cognitive load? The definition is the how much a developer needs to think in order to complete a task. And the idea here is that confusion costs time and money. So cognitive load's going to impede developers' most important responsibility to me, which is providing business value, providing value to their clients. There are two types of cognitive load that we're going to focus on. The first one is intrinsic. That basically means the difficulty associated with the problem that you're actually trying to solve. And then extraneous, which is the difficulty imposed by factors outside of the problem that you're trying to solve. And a nice sort of little graphic to sort of capture this is we have an example where a task was implemented and the complexity is in solving the problem versus the complexity is that really smart developers like architectural patterns that he likes to use, or maybe he pulled in some fancy libraries that didn't tell anybody. What are some examples of cognitive load? So again, cool, complex to architectures. I've at least used domain-driven design and clean architecture enough to know I shouldn't be using them for a blog. Poorly documented code or systems, that's kind of my favorite, one of my favorite one. Opening up, or kind of tangential, is like opening up user stories that don't have any acceptance criteria, and now I'm suddenly a project manager. Fancy libraries. I'm old enough to remember when GraphQL wasn't a thing and we survived, and now it's kind of everywhere. So it has very specific use cases, but it doesn't necessarily need to be everywhere, and that kind of goes together with the trendy technologies. And then the last one is multi-domain teams, which is kind of near and dear to my heart. Again, since I'm a full stack developer, I generally have to not necessarily wear multiple hats, but work in multiple code bases that might span across an entire project. So how can we combat cognitive load? So there's another talk that I give that talks about cognitive load and how it fits into like the whole developer experience and how it works together with like feedback loops and your flow state to help you be more productive and happy. But for this talk, we're just gonna focus on one thing, and that is primarily limiting responsibilities, or again, for this talk, simplifying domains. So how can we simplify our technology stack as much as possible to help our performance? So that leads me to developing horizontally. So what you see in this graphic here is we have two developers working on a product. You have a front end and a back end, and you have a front end developer and a back end developer who control those areas respectively. And what this normally means, the trade-offs are that you're focused on shipping tasks, not features. So maybe we're working in parallel, or maybe we're working in some sort of staggered format. Basically that means I ship my piece, and then the back-end developer might ship his piece, and then maybe we integrate, or hopefully it all just works correctly. What that normally means is you have a great amount of horizontal knowledge, but not as much vertical knowledge. So your front-end developers tend to be front-end experts, your back-end developers tend to be back-end experts, but maybe your knowledge of the pieces that you're working on and how they fit in the business on the whole isn't as great. So the alternative there is developing vertically, and what you see here is you have a full stack developer who's developing across the entire stack. Basically what that means is you're shipping features rather than tasks. So if I'm working on a authentication feature, I'm shipping that entire feature, not just shipping the authentication portion for the front end. What that generally means is that you tend to have a great amount of vertical knowledge, but not as great in terms of your horizontal knowledge. So again, using myself as an example, I'm generally more of a front-end expert than a back-end expert, but when I'm working on features, my knowledge of the business value and the thing that I'm creating should be higher because I have to touch everywhere and not just touch my portion. All right, so what are some of the trade-offs of vertical slice development continued? Generally speaking, it's great for product teams, but not so great for functional teams. So if you work on small teams, which I generally tend to work on smaller teams and doing greenfield development, then it's normally better for all of your developers to sort of fully understand everything. And then you're just by nature of the size of the team, you're generally going to be touching everything. But if you work at a place where maybe they have like back-end teams that service specific products, or they have like platform level teams, then vertical slice development is going to create more cognitive load than it gets rid of. Also, it's great for vertical knowledge sharing. So again, going back to the idea that your knowledge of the business tends to be greater. But the downside, again, is that you're increasing the cognitive load. And that goes together with the context switching. Basically, you're handling multiple domains, so your cognitive load is going to increase. Also, no feature, nor horizontal feature juggling. So the idea of working on your piece and then chucking it over the wall generally should be gone. And then last, it should translate to faster development cycles. That's not always true. Again, if you're managing multiple domains and the languages are different enough, then that can increase your cognitive load, which is going to lead to slower development cycles. All right, so enter monoglot vertical stack development. And all this basically means is that you're constructing a system using a single language. And in our case, we're going to be looking at Flutter and Dart. All right, so what are the benefits? Learn the language once and write everywhere. So I can write the same language on my back end, on my front end, which generally should mean that you have less context switching. That's going to improve your developer efficiency. Hopefully it'll lead to quicker onboarding because again, you only have to teach that language once, and if they already know that language, they should be more effective on day one. And then finally, code reuse. If you've ever built things full stack and you're using multiple languages, there's always like some serialization logic that you want to share or some business logic that you want to share. Maybe you're validating on both sides. Well, you can reuse that code if everything is written in the same language. All right, so some examples of monoglot. If you're coming from a JavaScript background, Expo, if you're familiar with React Native, Next.js, again a React product, Remix, again a React product, SvelteKit. All of these things are generally built around the Node ecosystem. If you're talking about like Android-specific developers, you can look at like Kotlin multi-platform, Kotlin server-side. If you're talking coming from an iOS side, Swift and Vapor. .NET side, you could talk about Maui and Uno, and then obviously .NET. So there are a ton of different examples of monoglot. All right, so full stack Dart, again, I'm not assuming that everybody in here knows what Dart and Flutter are, so we're just gonna briefly kind of look at what that, or talk about what they are, why they're useful, and then look at some code examples. All right, so what is Dart? Dart is a strongly typed object-oriented language that is optimized for UI development. So the strong typing essentially allows your Dart applications to compile down to machine code, which would increase your performance. And then it's also developed by Google. That's a good or bad thing, depending on your opinion of Google. And then the last one, it is the language that the browsers hate. So like a little bit of history of Dart. Dart was actually created by Google and pushed as an alternative that was supposed to replace JavaScript. The browser vendors outside of Chrome didn't like that. They were already like, we already have to sort this one VM. Now you want us to sort it to support this other one. So they politely told Google to kick rocks. What is Flutter? So Flutter is an open source reactive framework. It's very similar to React, and you'll see in the examples how similar it is. It supports mobile, web, desktop, embedded. Basically, any platform that you need support for, Flutter can support. It's being used in some very interesting ways, everywhere from like for your Android Auto to like your watch. It uses the Dart language, and it is also developed by Google. All right, so what is Flutter? Again, hopefully you can see this, this graphic, but this would look almost exactly the same if we were looking at React. So the idea here is that it is a reactive framework. Your events flow up, your state flows down. So here we have some UI. That UI is rendering a user input, a button. That button is clicked. That click causes an event that updates some state, and that will re-render the UI. All right, so Flutter started out as an experiment called Sky. I think 2014 was Dart Summit. Yeah, Dart Summit 2014. It was the brainchild of Ian Hickson and Eric Seidel, who are both were at the time working on the Chrome teams. Ian Hickson implemented the HTML5 spec. Eric Seidel implemented the SVG spec and also implemented it in the browser. So if you hate those technologies, you can blame these two people. The idea here was, what if the browser broke backwards compatibility? So what if we broke all of the technical debt that browsers had accrued over the last like 30 plus years? What if we got rid of all that? And what they ended up with was a platform that was significantly faster. I want to say like 20 times faster than the browser, but obviously you can't replace the browser because of backwards compatibility. So they repurposed it, and it will become eventually Flutter. So why would you be interested in Flutter? Well, the first question that I'll answer is whether or not Flutter is popular. This graphic, I love this graphic because it basically changes and goes up like every year. This basically shows all of the cross-platform solutions, the market share of all the cross-platform solutions dating back to 2019. So you can see 2019, Flutter was around 30%. React Native was dominating the market share, and you fast forward today, that's completely flipped on its axle, essentially. So Flutter now dominates the market share. React Native follows by pretty closely, and then after that, the drop-off is pretty significant. So the next question is whether or not Flutter is heavily contributed to. Since it's an open source project, like you use like the number of contributors and the level of popularity to sort of determine whether or not it's something you want to use. So Flutter is third on the list of open source projects by contributors, behind VS Code and Home Assistant. The second one I'm not familiar with, but I'm sure everybody is familiar with VS Code. So use that again as a metric to determine whether or not it is worth investing in. And then the last question is, who uses Flutter? I'm sorry if this moves a little bit too quickly, but basically, essentially everybody uses Flutter. Like the big names that were just announced were Universal Studios is using it for its applications that users use to interface with and navigate their sites. Disney is also planning on using it. It's being used again for everything from like games, if you're talking like, not ByteDance, but PUBG uses it for games, to auto companies like eBay Motors, they use it. All right, so Flutter's ideas are not new. Flutter ships the framework with an application. This is no similar than if you're doing game development using like a Unity or Unreal. Basically, you're shipping the entire framework every time you build your application. Flutter supports multi-platform targets. So this isn't different from React Native, Xamarin, Maui, what have you. And then finally, it has an extensible component system that you can override all the way down to the canvas layer if you're feeling dangerous. And that's no different from web, Android, or iOS development. What differentiates Flutter? I like to say that it provides cost-effective feature parity, and it provides availability and reliability. So the cost-effective part goes to the developer experience of Flutter and the ability to support multiple platforms. If there's a platform that doesn't exist, you can build your own sort of platform level architecture and support that platform. And then in terms of providing availability and reliability, because you're shipping the framework with the application and the framework is busting you all the way down to canvas, you can safely assume that your app is going to look the same across all of your platforms. And then reliability, because we are compiling down to native code, we should have very reliable performance. All right, so this is a speed dating code intro of a Flutter application. Here we're, again, this is written in Dart. So here we're importing Flutter material, which it gives us all of the widgets and theming for a material application. So if you're building an application that you want to look like Android, then you'd use Material. If you want to build an iOS looking one, you'd use Cupertino. But then also if you just wanted to style it however you want, the Material theming has much better styling generally than Cupertino. We have a main function that's the entry point for our application, and we're using the run app function that's provided by provided by Flutter to say we want to run this application. We're passing in a stateless widget that's called main app. There are two types of widgets in Flutter, stateless and stateful. If you're coming from React, this is similar to like React when you add React components versus functional components. The main difference here is that a stateless application or a stateless widget can only change when its properties change, versus a stateful widget can change using a set state function. So we have our main application. We have our build function, which is similar to a render function if you're talking about React again. And then inside of that, we are using a material app to basically set up our material theming. We're setting the home screen to a scaffold, which the scaffold is going to be the layer of the application, layout of the application. So your body, your bottom navigation, your top bar, all of those things can be configured with the scaffold. And then last but not least, we are centering some text that just says hello world. All right, so next up, we're going to talk about full stack Dart. The specific options that we're going to look at is implementing something using a minimalist framework versus implementing something using a full-fledged backend framework. You can also just use Dart. Like Dart includes all of the low-level primitives for creating your own server. And then there's also a library called Shelf that was built by the Flutter team that kind of wraps all of that functionality in an Express-like framework. All right, so the framework that we're going to look at specifically first for the minimalist side is called Dart Frog. It's open source, it's created by Very Good Ventures. If you've never heard of Very Good Ventures, they're considered one of the top consulting companies for like Flutter development. It has a very simple API. It's very Next.js inspired. And like Remix is where they'd like to get to. So like the idea being that you can have like your fully typed stack and sharing all this code, but it's very much more in like a next state right now. some of the features of Dart Frog. It supports hot reload. So one thing we didn't talk about is like the hot reload capabilities of Flutter. You have various fast development cycles because you can reload and your state is maintained as you're developing something locally. Your state is maintained, you're on the same page versus it kicking you out and having to go back to that page. It also plugs into Dart DevTools, which we didn't talk about. Dart DevTools is either an extension that you can use in VS Code, and I think Android Studio, or you can pop open a Chrome window and it's basically like a dashboard that you can use to debug your application. It has file system routing. So again, going back to the Next.js sort of influences, you define your API structure or your endpoints by using like your file system and your folders to basically specify which endpoints are what. It supports middleware. So again, a similar idea. You can define middleware at any folder layer, and that middleware will only apply to the endpoints defined in that folder. And then two features that they plan on working on, again, trying to be more like Remix Run, is full stack type safety with client generation. So the idea that you can define your endpoints and then all of your client library will be generated for you. You can just plug that into your application. And then API documentation generation. So if you're publishing an API that other people want to consume, the ability to provide like an open API spec that they can then take and generate their clients. A very simple Dart Frog example we have here is just going to return hello name. So here we have a route that's defined at hello and takes in a parameter of name. You specify the path parameters by using brackets. So what this would look like is if your API is hosted as /API, it would be /API/hello/Ryan. Here we are importing the Dart Frog package. We are creating a function that's called onRequest. So this is convention based. Essentially, Dart Frog will analyze the file and say, I'm looking for this particular type of method. So it's looking for that onRequest method that returns a response. This method takes in or passes in a request context for if you want to check like your HTTP headers or anything like that. And then it also passes in the name parameter that we have essentially defined in our folder. And then we're just returning a response with a body of hello and then the name that was passed in. And this would be a textual response. If you wanted to use a JSON response, it would be like response.json. The next option that we're going to look at is a full-fledged backend framework. This framework is called ServerPod. ServerPod is open source, but it's slightly different from VGV in that ServerPod is its own company. So VGV is a consulting company. ServerPod is its own venture-backed company. It's backed by a Googler, Victor Lidholt, who worked on the Flutter teams, I want to say around like 2015, 2016, so early stages. And it is a full stack framework that's inspired by the likes of Ruby on Rails, .NET, etc. What are some of the features of ServerPod? So the big one that kind of differentiates itself or one of the big ones that differentiates it from Dart Frog is it has RPC-like communication and serialization. So as you're building your endpoints, you have CodeGen that's going to generate your client, and then you can import that client into your Dart application or your Flutter application and just start using it. It has DevOps included, so it also generates the Docker and Terraform files for your application. I think by default it generates them for AWS, but then you can go and modify them as you see fit. And then it has built-in support for logging, ORM, caching. It handles more complex features of application development like task scheduling, authentication, uploading files or file storage. So basically, they've identified like the vast majority of features that you're going to use, like a .NET or Ruby on Rails, the vast majority of the features that you're going to use when you're building an application, and they provide resources around that. And then last but not least, similar to Dart DevTools, they have a companion application that you can use for local development as you're building your API. Also, a feature that they are working on now is ServerPod Cloud, which basically the way that I would sum it up is Vercel but for Dart. So basically, they have a cloud offering similar to Vercel that can analyze your API at build time and deploy or scale all of your cloud infrastructure when you're building. And the idea there is that it should ease your deployment, it should provide global availability, and it should be cost efficient. I don't know if that's actually true. Vercel really isn't cost efficient, but we'll see when it ships. What does a simple server pod example look like? So if we use that same example that we previously saw, here we have our example endpoint. Our endpoint is called hello. We take in a session object, which the session object is very similar to that context that we saw before. And then we have our string name here that we're passing in, and we're just returning a textual response that says hello plus the name. And then what does it look like then when we're consuming this endpoint? So again, this was all generated. We didn't have to do anything extra to get this functionality. Basically, when you create a server pod project, it includes your API, your app, and then the shared sort of code-gen layer between them. So if we were to run that example that we just saw, we would have a code-gen client.example.hello that we could pass in our world to. So what are some of the differences between ServerPod and Dart Frog? So the immediate one that stands out is built-in code gem, not just for your code, but also for like Terraform. Built-in migrations is a thing that we didn't talk about, but again, it provides you with an ORM, so it can handle the migrations as you're building out your database. Built-in resources, so those resources that we saw for everything from like logging to task scheduling. And the downside, I would say, is that it has very strong opinions. So as with any full-fledged framework, it's kind of up to you to sort of analyze whether or not their opinions are necessarily where you want to be. Like, if what they're providing is what you need, then it's great. But if it's not, then again, going back to the old idea of cognitive load, you're going to spend more time fighting with the framework than you are being productive. Dart Frog, on the other end, has file-based routing, which we saw. It supports RESTful conventions, so that's one major difference there is, again, ServerPod is building like an RPC-like API versus Dart Frog is building like RESTful conventions. So if you were sharing this API out in the world, it might look a little different, or you might have to do some manual stuff to build an API that other people could consume. Next.js influenced middleware, so again, being able to define middleware at any layer that can be applied. And then simplicity, like you think about this as like Express, again, versus like a Nest.js. So Express, extremely flexible, you can do a lot of things with it, versus Nest.js, extremely powerful. So another option that we're gonna look at that is also the Vercel of Flutter is called Celeste. Celeste actually came out before ServerPod Cloud was announced, so I wonder how much of that was just them stealing Celeste's roadmap. But they are also their own company, venture capital backed, the Y Combinator success story, and backed by some of AWS's Amplitude alums. Yeah, I talked about own company. Some of the features of Celeste, very similar to some of the features of ServerPod. Full stack type safety. Currently, they only support authentication and functions. So the idea is that they want to support sort of all of those resources that a ServerPod supports, but they came into inception in January, so they're fairly new. Dart native. So one interesting difference between ServerPod and Celeste that I didn't talk about is serialization. The way that you serialize and map your ORM to your database is using YAML files, which is a little weird to me, versus with Celeste, you basically use method indicators. So you add a method indicator that says this is a cloud function or this is for authentication, and that's all generated for you. So again, you don't have to leave one form of code and go to another. Everything is just done in Dart. And then backend as a service. Again, this is a very much a Vercel-like offering. What does a simple Celeste example look like? So this should feel a little bit repetitive by now. Basically, we're importing the Celeste framework. We have an indicator saying that we are defining a cloud function. That cloud function just returns a future, which a future is very similar to a promise of string. And it's the method is called say hello. We pass in the string name, and then we just return hello plus the name that we passed in. So what are some differences between ServerPod and Celeste? So obviously, ServerPod is more feature complete. ServerPod has been around, I want to say, for 3 to 4 years now. So they've had a significant amount of time to build out all these resources. It's also more established and well-funded. And it's also more flexible, again, going back to the idea that it's feature complete. Like, you can do a lot more exotic things than you can currently do with Celeste today. From Celeste's perspective, it's Dart native. You don't have like an extra serialization step, so you don't have to mess around with configuring your serialization or your ORM. You should have less cognitive load by nature of the fact that it's all just Dart native, but then also by nature of the fact that it has significantly less features. And the downside there is you have less flexibility and then also potential vendor lock-in. So Celeste, basically you can only build a Celeste application if you're deploying to Celeste Cloud. So obviously that's going to hinder you. If you were to decide one day you want to migrate away from Celeste, you would have to either rewrite your code in a way that's clearly abstracted, or you would just have to rewrite everything from scratch. So that's all cool and fun, but the one thing that we really didn't talk about was infrastructure. So it's nice that we have these platforms that help us build our applications, but configuring infrastructure is a whole extra area of like cognitive load, or a whole nother domain that we have to manage separately, either using like a Terraform or a Pulumi, or any of those infrastructure as code frameworks. All right. So that brings me to talking a little bit about infrastructure from code. And the whole idea of infrastructure from code is that you infer your application infrastructure or your cloud infrastructure from your application code. So let's say we go back to one of those previous examples, or we just use Express as an example, and you have like api.get and just like hello. Well, basically at build time, the framework that you're using or the platform that you're using can inspect that code and say that I see that this is a HTTP GET request. What you really mean is that you want a Lambda to handle this request, and it's sitting in front of or behind API gateway, and it'll basically build all that for you. You didn't have to do anything extra to set up that infrastructure. I like to call infrastructure from code an abstraction, not a replacement for infrastructure as code. So on the left, you have the infrastructure as code. You have like Terraform, Pulumi, CDK. And the difference is that infrastructure from code, again, is just an abstraction on top of those things. So you can still use Pulumi, Terraform, but you don't have to. Like, if all you need are the resources they provide for you, then you'll be just as effective. And the one that we're specifically going to take a look at is Nitric. What are the benefits of infrastructure from code? So again, it's self-provisioning infrastructure. It's basically all automated for you. You didn't have to do anything special to get that. You didn't have to write any Terraform or Pulumi. Portability across technologies and providers. So again, this is an abstraction. This is one of the areas where I think like infrastructure from code falls short, is they don't really provide abstractions on top of these cloud providers. So when you're building something in Pulumi, for example, you are very much saying, I am defining an API gateway for AWS or an API gateway for GCP. And then again, focusing on code, not infrastructure. So shrinking the amount of domains that we have to manage should allow us to be a little bit more effective. So Nitric, I actually coined the term Flutter for the backend, and the Nitric team said that they were going to steal that because they really liked it. It is a cloud-aware application framework. It is, like I think all of these minus Celeste, open source, investor-backed, 100% free. Basically, a bunch of backend / DevOps guys got together and said that we hate rewriting this over and over again. So they built this thing and they said we're going to make it open source and free. And the idea here is you can learn once and write everywhere. So again, this is an abstraction that basically you're just saying, I want an API, and then at build time you say, I want an API in GCP, or I want an API in AWS, and it abstracts away all that complexity. You just build that API once, and you can run it or write it everywhere. Some of the features of Nitric, so it is multi-provider. Again, write once, deploy everywhere. The one that I'm really fond of is the fact that it is language agnostic. And why this matters to me is because let's say I work at a company and we're lucky enough, in my mind, to use Dart everywhere. But then I go to another company and we're using TypeScript, but we're still using Nitric. Then the amount of cognitive load in my onboarding experience should be significantly lower than if we were using two separate frameworks. Let's say we were using Fast API over here in Next.js, or one of the frameworks we just talked about over there. My cognitive load should be smaller. Sure, the language is different, but the primitives that I'm interfacing with, the resources that I'm using are the same, so I should be more effective from day one. DevOps optional. So Nitric is built on top of Pulumi, but it allows you to write your own Pulumi. So if you want to integrate, bring your own. Or it allows you also to generate Terraform scripts instead of Pulumi that you can modify at build time. It supports auto-scaling serverless primitives. So it's essentially they've mapped out all of the serverless primitives that are consistent across the big three platforms, so GCP, Azure, and AWS, and they said, okay, let's build some resources that expose these primitives. So API gateway, tasks, file upload, key value storage. Just recently, they released their SQL database layer. There's more than that, like WebSockets, stuff like that, but we're not going to go into all of them. It supports fast local development. So one of the biggest pain points if you're doing serverless is how do you develop locally? Basically, they provide an emulated environment similar to Dart DevTools that opens up a browser, allows you to test all of your resources and inspect them, see what they look like. That DevTools also includes architectural diagrams. So again, going back to the idea of being able to onboard quickly, if I were working in a Nitric project and a new developer came onto that project, then on day one, they could run Nitric start, and they could go to the architecture screen, and they could see a diagram of the entire application, how each endpoint or each resources maps to code, and I could navigate from that diagram directly into my VS Code instance. And then on the other end of the spectrum, since we're using Pulumi, when we're deploying the thing, the Pulumi dashboard allows you to inspect your entire stack. So being able to map the code that you wrote to the actual resources in AWS, for example. And then the last one, like I harp about this every time I talk about Nitric, they have some of the most empathetic, experienced code owners that I've worked with. The reason that they support Dart is because I gave a compelling argument in their Discord channel for why they should support Dart. They were like, oh yeah, that's cool. And then 3 weeks later, they were like, we support Dart. Same thing for like SQL dashboard. Like you give a decently compelling argument for why you need those things or supporting SQL. And they go off and they figure out how to implement that thing. So how does Nitric work? So starting in the middle, you're using that language SDK, you're building your application code, you're using the Nitric CLI to test and run locally, but then once you actually decide to build your thing and deploy it to the cloud, your Nitric API will ship with a sidecar that basically talks between the services that you're using and your API is basically, again, an abstraction over those two things. So you have some runtime plugins there. You have some deployment plugins that basically say this is the cloud provider that I want to deploy to. And then those are the three cloud providers supported out of the box: AWS, GCP, and Azure. You can write your own interface to interface with other cloud providers. They actually have a really good tutorial that basically talks about deploying to DigitalOcean, like basically building part of your stack to support DigitalOcean and deploying to that. So it's a fully featured but also extensible framework. All right, so what does a Nitric API look like? So keeping the theme consistent, here we've defined a API gateway that's going to be called public. So if we were in AWS, you would be able to see public somewhere. We're saying that we want to handle a post request. I'm not sure why I made this a post request. It should be GET. But we're saying we want to handle a post request to hello/name, where name is the path parameter that we're passing in. Nitric provides us with a context similar to that context that we saw from Dart Frog. And then we're just grabbing that name argument from the path parameters. We're setting the response body to hello plus the name, and we're returning that context. This is a somewhat more complex example that also demonstrates what the architectural diagram that's generated for you looks like. So here we have two separate API gateways. We have one for library and one for patron. Library is fully defined in our books API Dart file. Patron is defined in the patron API Dart file. And then also, our library class triggers some WebSocket subscriptions to notify users when the books have been returned or borrowed. Okay, so Nitric versus the field, what's different? So fully open source, but backed by backend experts, which I think is an important differentiator here. Most of the frameworks, I think all the frameworks you've seen today are mostly backed by people who specialize in front-end development. These are, again, backend guys who specialize in either building APIs or DevOps. Self-provisioning primitives, this is something that none of the other providers we've looked at support. And then that emulated cloud environment that's going to simulate what it feels like to deploy something to the cloud and what those resources look like, and allow us to play around with those resources. That's, again, something that's very different from the other providers that we looked at. Versus the field, we've looked at mostly options that are all Dart native. So Nitric, they basically code gen all of their SDKs. So they use gRPC to code gen all of their clients, including their Flutter client. And then they have like a thin wrapper, a thin Dart wrapper, or a thin whatever language you're using wrapper. Built by Flutter experts. So again, key differentiator is backend experts versus Flutter experts. Feature parity varies, so we saw examples where there's ServerPod, which has all the features in the world, versus like Celeste, which is very much in its introductory or infancy stage. And then you got to bring your own infrastructure. So the one thing that Nitric provides that the field doesn't provide is the idea of self-provisioning infrastructure. All right, so conclusion. We learned that cognitive load is heavy when it's heavy. So as much as possible, we want to reduce the amount of extraneous cognitive load that we have so that we can provide as much business value and hopefully be a little bit happier, solving on business problems. Monoglot development can reduce cognitive load and increase productivity. So we talked about the idea that doing things multi-domain when you're using multiple languages and multiple technologies can increase your cognitive load, but if you can, again, simplify the domain in your tech stack, you should be able to increase your productivity. And then finally, we looked at some of the different approaches for building applications using Flutter and full stack. If you'd like to learn more, I have the three frameworks that we looked at: Nitric, ServerPod, and Dart Frog. They all have various connections on their web pages. So Nitric uses Discord. I think ServerPod uses Discord as well. I'm not sure what Dart Frog uses, but all of those platforms, the guys are very friendly. A lot of resources about cognitive load. The really great resource is the one on DevX and what actually drives productivity, and that talks about how cognitive load, feedback loops, and flow state kind of work together to help you be productive. And then again, some more research about cognitive load, and the last one is just about how software teams are normally organized. And then for my last slide, I actually just published a full stack Dart workshop. It is free, I think, for the first 105 people who sign up. So you can use that QR code, or you can use that bit.ly link. I promise that it's not going to hack your computer. And then these slides, you've seen the link pretty much everywhere, but chimon.dev, you can find the slides for my 2 talks that I've been working on this year. And I'll also share this link out in the Zulip channel. And then also, if you have any feedback as well, I would love to get your feedback on this talk. So you can either use that QR code or you can use that form link there.